Hey guys, it's Mrs. Gauthier. Thanks for coming back for our last lesson of chapter 6. All right, so for the first part, I kind of was looking back at stuff and I was like, ooh, you guys don't have all of the shapes didn't all turn up here. So don't worry about doing those problems because they're not on your sheet. We're just going to start with this part that has us calculate the value of the expression. So 6 divided by 1/2. Remember that when we're dividing by a fraction, it actually is going to get larger. So in this case, we can just say 6 times 2, right? Because it's like doing the opposite with your key flip change, which would equal 12. And then if we do that again, so 4 times, right? Keep the first number, flip the symbol, and then change your last fraction. That would be 6. Okay. Oops, sorry. Those ones are just kind of procedural problems. All right, next up, examine the triangle below, this guy, and then redraw it with sides that are a third as long as the sides of the original. So we can do that. Obviously, I don't quite have enough room to make it like exact, but we can multiply each side by that 3, remember? 45. All right, so now we have to calculate the perimeters of both triangles. And I realized that you don't have a bottom number here. Something must have gotten chopped off. I'll fix it for next year. But remember, perimeter, we're just adding up all of our sides here. So our first, and then the same thing on this one. So for this guy, our perimeter would be 36. Oh, for this guy, it would be 36 meters. Oops, I totally did this part off. I was supposed to divide, and I did not. Now the whole desk is like falling apart. Okay. There. Okay. So 3 and 5. There we go. That looks better. And then 12. I went the wrong direction. I was trying to do that quick and did not work. All right. And then the areas. Remember, area of a triangle is 1/2 base times height. Okay. So our areas, right, this is the base of the triangle, this is the height of the triangle. So when we multiply it, and you could just do like 0.5 times our base times our height, we would get 54 meters squared and 6 meters squared. Okay, so what is the relationship between these two? The perimeter is 1/3 as long, right? It's 1/3 of that. Okay. Flipping it on over to my other side here. So on there we go, 105, it says that Lucy and Marissa each designed a box plot to represent this data in a set. So we have the information that's given. Their plots are shown below. So we have one here and we have one here. Which plot is scaled correctly and why? And then we have to explain the mistake that the other person made. So first of all, when we look at the information, we can see 16, right? It should be our smallest number on each, which it is. So that's a good place to start. We can see that 35 is the last, also good. Then when we go ahead and we look at our median number, right? So the number in the middle. So we're kind of doing that narrowing down, right? It should be 25 is in the middle. This one, it's like a little bit farther over. And then our first quartile number should be our like 19-ish, right? Now on this one though, we see that it's not, right? The first quartile is like 18, which would be incorrect for this information. So that tells us right away that this box plot is done correctly. So we can say correct since it has both the equal space number line just abbreviate number line and box plot. This one does not work because I'm missing, right? I'm like missing some numbers. There's like numbers that are repeated. It's not good. So we need they need to include an equally spaced number line, right? That's the issue. That's numbered. I'm just going to abbreviate incorrectly. So do you see how it doesn't go up by the same amount every time? That's one of the issues. All right, then 106, we have to draw the coordinate graph and then plot the points below, and then we'll have to do some reflecting and whatnot. So first we're going to get these plotted. So -3, 1. So -3 on the x, 1, 2, 3, and then up 1. Don't forget to label. That is letter A, or point A. And then B is at -1, 3. So over 1, up 3. Sorry, Rika is meowing at the door again. Oh, she does not want to leave me alone today. For C, we have to move over 4 because it's positive. 1, 2, 3, 4 to the right. And then up 2. C. And then our last one, D, is over 2. And then we just stay put. So D. Looks like that. Okay, there we go. So what is the shape that we created? Well, it's called a parallelogram. Parallelogram. There's only one L, sorry. Okay, then it says we need to reflect the shape across the x-axis and list the new coordinates of our new point. So first, let's do that. Reflecting it over the x. So we know that this is our x. So again, we're just going to take each point and redraw it down here, count how many spots away from the x, the line of reflection it is. So for instance, like this D point is not going to change at all because it's right on the line. A, however, is 1 up. So we just are on that same longitude line. We just come down 1, and that's our new point, like A with a little tick mark for new. B, we can see, is 1, 2, 3 points away from our line of reflection. So that means we need to come down 3. 1, 2, 3 for our new point B. And then C is 2 away. So we can plot him right there. All right, and then we're just going to connect our points right in here. And you can see, whoa, that one was not super straight. You can see that it's the same shape, just reflected over. So now we just have to name these points. So we can see that point A right here. A is at -3, -1. B, right down here, is at -1, -3. C, right there, is at 4, -2. And then our last one is at the same spot, right? D didn't change at all. All right, now it says multiply each of the coordinates of the original shape by 3 and then graph the dilated shape. What are the new coordinates? All right, so let's just do, we'll write out the new coordinates since we're multiplying by 3 first, which means that we need to know what the originals were. So we're just going to look back up here, and we're multiplying all of these by 3. So -3 times 3 is -9. 3 times 1 is going to be 3. So that's point A. Point B, -1 times 3 is -3. And then 3 times 3 is 9. Oops, sorry. I'm trying to show you both and I can't fit it all on one screen. So point C is 4 times 3 is 12. And then 2 times 3 is 6. You can see it on your sheet at least. And then for D, 2 times 3 is 6. And 0 times 3 is 0. So that part stays the same. Okay, so now that we have our points, we just need to plot them on our new graph. So -9, 3 means that we're coming over 9 on the x here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 3. So 1, 2, 3. All right, that becomes our new point A. B is at -3, 9. So 1, 2, 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, way up here. Okay, that's new B. C is at 12, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then up 6. 1, 2, 3, 4, 5, 6. That point right there is our new C. And then D is at 6, 0. 1, 2, 3, 4, 5, 6. There we go. And that's D. All right, and then we just connect our points here. Try to keep straight lines. Maybe use a ruler because mine's starting to curve right there. It makes it not really look like a parallelogram. Sorry, I have to turn mine to get this last line here. Should we try and fix this guy? There, that's slightly better. The other one had such a curve. All right, anyways, it should look like a parallelogram, just a larger one. Okay, so next, there is actually more. Because it's like there's that third page here. Or what are we on, the second page? There's 3 altogether. It's kind of a lot for this one, but there's a lot that we're trying to prep you guys for the test. All right, so 107 says to look at the diagram at the right. There's a smaller diagram, right? Triangle that's right here. And we're going to write and solve a proportion to figure out what x would be. Okay, and it may be helpful to draw the 2 triangles out separately if you can't like visualize them both there. So we know we have to find x. So I'm going to start by putting x into my proportion. And then I need to figure out what side matches up with x. So for this small triangle, it's like this height. And so the height of the large triangle I can see is 8. So that comes right there, which means it's going to match up with it. And then I need to figure out 2 sides that I already have. So I already have my base here and then my full base of my big triangle. So my small base is 8. My large base would be 8 plus 10, which is 18, right, for this whole distance. So now it's just like solving any other proportion. You can cross multiply. So like you can do 18 x. Yeah, wait. Okay, yeah. 18. I'm like second guessing myself all the time here. All right, 18 x plus 8 times 8 is 64. And then you would divide by 18. So that, and then that. Divide by 18, and we would end up with actually a fraction. So it's okay. You can keep it like this, or you can write it like 3.5 repeating. It's not a nice decimal, unfortunately. So, okay. Next one, number 108. So a figure is rotated and reflected. What can you say about the new figure in reflection to the original figure? So you have to kind of take a minute and like think about what they're actually asking. So you have a figure, it was rotated and reflected. So what happened to it? It's still congruent, right? Meaning like it didn't change the size at all. So the 2 triangles are congruent. Okay. A figure is translated, so it means it's like slid, and then reflected, right, flipped over, and then dilated, meaning it got bigger or smaller. What can we say about the new figure in relation to the original? Well, it's not going to be congruent, right, because it was dilated. That's that big word right there. But they are going to be similar shapes. Meaning like the sides are proportional. So we didn't like completely change the shape of the figure. We just changed the size. Okay, next up, a little bit of review. So for each situation given below, we have to complete the representations web, meaning like a rule, a graph, a table, a tile pattern for each of our situations. Okay, so let's start with an XY table because we're already kind of given that information. Okay. So I know I need figure 0. 1, 2, 3 is fine. We don't really need more than that. Okay, figure 1 has 4 tiles. Figure 2 has 6 tiles. Figure 3 has 8 tiles. So what is our growth? What's happening every time? Well, I can see I'm adding 2, right? So then to find my 0 number, I'm just going to subtract 2 from 4 to give me 2. And now I can write a rule. So y equals my growth, remember, was 2x. And then my 0 number is right here, plus 2. So now I can go ahead and graph. I could graph the points. I'm just going to graph based on the rule because it's a lot easier and faster. It's more efficient. So I'm going to find 2 on my y-axis matching up with the number that's not with the x. And that's my starting point. And then my growth is 2, so up 2. Since it's positive growth, I'm going to the right. And I can also grow down by going down 2 and then left 1. And there's my nice little line. Make sure that you have a few points on there. All right, next up. For letter B, I'm given a rule, and I have to create a table and graph. So again, just like 0, 1, 2, 3 is plenty of points. We don't have to go crazy. We know that our 0 number is 7, right? Because that's what that number tells us. That's our 0 number. And we know that we are decreasing by 3 every time. So 7 minus 3 would be 4. 4 minus 3 would be 1. 1 minus 3 would be negative 2. And then we can go ahead and graph. I'm just going to graph off of this rule. So finding 7, 1, 2, 3, 4, 5, 6, 7. That's my first point. Coming down 3, 1, 2, 3. And then since it's negative growth, I have to go to the right one. To make that hill that it's going to slide down. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. All right, and then we have our nice little line. Don't worry about doing a tile pattern for that one. We could create one. It wouldn't be too hard, but I think you guys can all create a tile pattern. It's these other pieces that might be trickier. All right, flip it on over. This time we're given part of a table. So again, to find the growth, we are going to look at our 2 numbers that were given. We're going to find the difference between them. So from 1 to 10 is 9 numbers. And then from 0 to 3, right? So this is essentially 1, 2. So 1, 2, 3 jumps. So 9 divided by 3 is 3. So that means our growth every single time is going to be plus 3. So 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 gives us 10. So our rule, y equals, what was our growth? 3. Then comes the x plus, what was my 0 number? 0 matches up with 1. So there's my rule. All right, now to graph. We're going to start with 1 on the y-axis. There's our first point. We're going up 3, 1, 2, 3, and over to the right 1. Up 3, over 1. We can also come down 3 to the left 1. Right? Remember how to do that? Okay. There is our line. One more here. We have letter D. We're given a graph. We have to create a table and a rule. That's kind of nice to not have to graph it, right? All right, so there's my little XY table. I can see that 0 matches up with 6. 1 matches up with 4. 2 matches with 2. I could figure out 3, right? It doesn't show me 3, but I can see that I'm adding 2, right, every time. So then that would be 0. Or actually, I'm subtracting 2, aren't I? Whoops. I'm always adding, so it just like comes naturally to write that. But I'm subtracting by 2 to get that every single time. All right, so for my rule, I have negative growth, so don't forget that negative sign. And we're subtracting by 2. Throw that x on there, and then your 0 number is positive 6, so plus 6 would be your rule. All right, perfect. Do we have more? No, that's it. Yay. Okay. Well, thank you guys for hanging in there. I know that's kind of a longer video, so I appreciate your patience. Please ask questions if things are not making sense, though.